So the main difference with this second portion for section 4 on polynomials is that we have this problem here, and where I see students trip up trying to cube this binomial 2y minus 5 is that they'll try to distribute the 3 to the 2y into the negative 5. So let's make a note up here. If you have this set up and you're cubing it, please do not evaluate this as 2y to the third, subtracting 5 to the third. It won't work out. Think about this. You're cubing this binomial. You're taking this and multiplying the binomial by itself 3 times. Even if you stop at just 2 versions of it, that's squaring it, and this would definitely give you some outcome that's not going to be 4y squared minus 25. So please take your time. Although we are going to be cubing this, at first I think it's easier to just evaluate it with just squaring it, and this is totally fair game. So you could think of this as 2y minus 5 squared, multiplying eventually with 2y minus 5. If you use box method for this, this is going to get you 4y squared. 2y minus 5 will get you to subtract 10y and then deduct another 10y, so minus 20y. Eventually adding 25 at the end, because it's negative 5 times negative 5. And this is what we then need to multiply with 2y minus 5. And this I'll actually show box method on. So we have this. I'll rewrite it over here. So this is using box method, where we have 4y squared minus 20y plus 25 multiplying with 2y minus 5. So we have 3 terms up here in the top, so I'll make sure that there are 3 columns. 2 terms on the side, so make sure that there are 2 rows. Taking products in all of these, 2y multiplying with 4y squared, 8y to the third, deducting 40y squared, adding on 50y, subtracting 20y squared, adding on, careful here, negative times a negative, 100y, finally concluding with deducting 125. So the diagonals are what we can combine. So this here is just y squared terms. Notice that. Here we only have y terms. So if we take this further, 8y cubed is leading this. Negative 20y squared deducting 40y squared gets us negative 60y squared. Adding on 150y, deducting 125. That's our final answer. Be careful with combining like terms here. Be careful when you are evaluating just like this. Like, don't fall for this. I'm begging you, please don't do this. Think logically. If you get stuck, rewrite it out. Use box method. Double check your work if you need to. Down here, we're taking the difference with these 2 products. Quick box method for these. Just jump ahead. 6x squared. We're then deducting 2x, but then adding on 15x. Finally deducting 5. So this should get us 6x squared plus 13x minus 5. So that's the first product. We're then deducting this product here. So we have 5x squared plus 10x minus 3x minus 6. Combining the middle terms, getting us here. This should look like a problem similar to problem 1 on this section. So if we combine like terms, We have x squared terms here and here. We have x terms here and here. So we know to combine these. We also have constants of -5 and deducting -6. So if we focus on our x squared terms, we have 6x squared deducting 5x squared, just leaving x squared. 13x minus 7x leaves us with 6x. -5 subtracting -6. Think of this as adding 6. So then plus 1. So final answer here is x squared plus 6x plus 1. If you have any questions on this section, anything with combining like terms or box method or FOIL method, please let me know in class. Although I jumped ahead showing how the box method worked for this example, if you need that, please let me know. If you need any clarification for the work that's here, please let me know. But again, using either foiling or box method, you should have that down pretty well. So please let me know if you're still stuck on that or if you need additional practice.